Good morning. Today we are going to discuss regarding switching. Switching is a concept that can be discussed at several layers. We have switching at physical layer, at data link layer, at network layer, even logically at application layer. We discuss this switching, say, not specific to any layer. We are going to discuss a general idea of switching in this module. As we know that a network is a set of connected devices. Whenever we have a multiple devices, we have a problem of how to connect them and make one-to-one communication possible. One of the solution is make point-to-point connection between each pair of devices. Example, the mesh topology, or between central device and every other device. The example is star topology. These methods are not practical and they are wasteful when applied to a large networks. The number and the length of the links require too much infrastructure and it is not that cost efficient. The better solution to overcome these specified problems, we need a switching. A switched network consists of series of interlinked nodes called switches. Switches are the devices that are capable of creating temporary connection between two or more devices. One example of such a connected network with the help of switches is shown over here. The devices A, B, C, D, E, F, G, H, so on are interconnected with each other with the help of switch. Here we are not using a mesh topology sort of a idea. We are interlinking these devices with the help of switches. Whenever A wants to have a link with F, he may use services of a switch 1, switch 2, 3, 4, and finally he will be get connected to F. This is one path to be get connected with the F. There are other ways of connecting with the F using the services of other switches. Switching is possible in three different ways. The first one is a circuit switching, second one is a packet switching, third one is message switching. So packet switching in turn again get divided into two categories. One is datagram networks, second is virtual circuit networks. Let us start discussing regarding a circuit switched networks. A circuit switched network consists of set of switches connected by physical links. A connection between two stations is a dedicated path made of one or more links. In circuit switched network, connection between the two stations is a dedicated path, this one, made of one or more links. Each link normally divided into n channels by using either a frequency division multiplexing technique or by using a time division multiplexing technique. In this figure, each link is divided into three sub channels. Okay, so because we are talking about three connections, so it is divided into three sub channels. So here n is 3. The inputs to these switches are multiplexed to use this output channel. Again, these end systems are either telephones or computers which are directly connected to these switches. Whenever this end system A wants to communicate with this M, first A needs to request a connection to M that must be accepted by all switches as well as M itself. This connection request is called as setup phase. During this circuit setup phase, a dedicated channel will going to be reserved on each channels for these two parties. After connection get established, the parties then allowed to transfer the data between them. This phase we call it as data transfer phase. Once all the data gets exchanged between a sender and a receiver, then they are allowed to say disconnect the connection. So this phase of disconnecting themselves from the communication is called as connection teardown phase. Whatever the resources that are reserved during the setup phase will going to be relinquished during the teardown phase. The resources that are reserved during the setup phase will going to be utilized during the data transfer phase. Those resources will going to be will be dedicated for this particular connection till they are in a communication or data transfer phase. Actually, during a connection setup phase, the resources will going to be requested to all these intermediate stage devices for establishment of connection between these two end parties. So if there are no sufficient resources available in any of these intermediate devices, in that situation these devices will going to reject the request that is made by one of these parties. Connection setup phase means actually reserving the resources along the path for communication between two parties. The idea of reserving resources during the connection setup phase will reduce the efficiency of circuit switch networks. So these resources which are reserved during the connection setup phase between two parties will not going to be utilized or used by other devices when they are not in a use. These resources will going to be dedicated for these two parties till they terminate their connection. Even though the efficiency of this type of switching circuit is low, but still when it comes to a delay that is experienced by data, so it will be very minimum in this type of case because already the resources are reserved well in advance for the data transfer purpose. But so in this circuit, in this type of a switching technique, the parties has to spend some time for establishment of connection and for tearing down of connection. So there will be some wastage of time for establishment of connection. Once a connection gets established, then there will be a dedicated resources available, so no data will going to experience a delay in intermediate devices. So this is what is an advantage of circuit switching technique. To utilize the resources in a better way, the packet switching concept has come into a picture. In packet switching network, there is no resource reservation in advance. Resources will going to be allocated on demand in packet switching networks. We have two types of packet switching networks. First one is datagram networks. Second one is virtual circuit networks. First we'll discuss regarding datagram network. In datagram network, each packet is treated independently of all others, even if packet is part of multi-packet transmission. This figure is an example of datagram network. So in this figure we are using switches which are traditionally referred as routers. So the message one which belongs or which is originated from station A, which is meant for station X, is divided into a smaller units known as packets, and each of these packets which belongs to a same message will going to be processed by these routers, say independently, and then these packets will going to be routed through different paths to reach the destination, okay, depending on the situation at that particular time. The datagram networks are sometimes also called as connectionless networks. The term connectionless means that switch does not keep information about connection state. There are no setup and tear down phases here. Each packet is treated same by switch regardless of source or destination. In this type of connection, each switch or router will going to maintain routing tables to transfer or to send these packets to a specific outgoing lines. Routing tables which are used to route the packets are maintained in the routers, and these routing tables are updated or built dynamically, and periodically these routing tables will going to be updated. The destination address and corresponding forwarding output ports are recorded in the table. In datagram network, every packet consists of header, and one of the information in the header is a destination address. Whenever this router receives the packet, it checks for the destination address in the packet header. Based on the destination header, so it will decide to forward this packet to a specific outgoing line. The destination address in the header of the packet in the datagram network remains same during the entire journey of the packet. When we talk regarding the efficiency of the datagram network, the efficiency of the datagram network is better than the circuit switch network. The resources are allocated only when there are packets to be transmitted. If a source sends a packet and there is a delay of few minutes before another packet can be sent, the resources can be reallocated during these short duration of time for other packets and other sources. There is no setup phase and tear down phase in a datagram network. Each packet may experience wait at a switch before it is forwarded. In addition, since not all packets in the message necessarily travel through the same switches, the delay is not uniform for the packets of the message. This is very much clearly shown over here. The packets which belong to a same message are traveling through a different paths to a destination. The packet 2 is traveling through this path, packet 3 is traveling to this path. So when we talk regarding the delay that is experienced by the packets of a same message, they are different. So there is no setup and tear down phase in datagram networks, but each packet may experience wait at switch before it is forwarded. In addition, since not all packets in the message necessarily travel through the same switches, the delay is not uniform for all the packets of the message. So consider the below figure in which our message is traveling through two switches to reach the destination. Total propagation delay that is experienced by the packet is 3 tau. Say this is, if I consider that the propagation delay between say every unit if it is tau, then the total propagation time for packet to reach a destination is tau plus tau plus tau, it is 3 tau. And total transmission time here is 3t, because first time the packet get transmitted by a sender, then the same packet, once it get received over here, it will going to be retransmitted by this switch. That is, again it takes one transmission time, and this again it will also retransmit the packet. So the total transmission time of the packet is 3t. So the total end to end delay consists of 3 transmission times, 3 propagation delays plus 2 waiting delays. The first waiting will go to be here. So once a packet gets received over here, it will be made to wait in this intermediate device. Thereafter it will be transmitted. Again the second wait will be over here. Next we will discuss regarding virtual circuits, virtual circuit networks. Virtual circuit network is a cross between circuit switch network and a datagram network. It has some characteristics of both. So as in circuit switch network, there is a setup and tear down phase in addition to data transfer phase. Resources can be allocated during the setup phase, as in circuit switch network, on demand, as in datagram network. As in datagram network, data are say broken down into a smaller units known as packet. Each packet carries an address in the header, but the address that is in the header of virtual circuit network is different from that of datagram network. The address here, it will going to be say contains what the next switch should be and the channel on which the packet should be carried. As in circuit switch network, all the packets follow same path established during the connection. A virtual circuit network is normally implemented in the data link layer, while the circuit switch network is implemented in the physical layer, and datagram network in the network layer. But this may not be all the time true, it may change in the future. In virtual circuit network, 2 types of addressings are involved. The first one is global address, the second one is local address. Global address is an address where source or a destination needs to have a global address that can be unique in the scope of network. This global address in virtual circuit network is used to create virtual circuit identifiers. The identifiers that is actually used for a data transfer is called virtual circuit identifier. Virtual circuit identifiers are the identifiers which are created by using a global address, and it is a small number that has only a switch scope. This identifier is used by the frame between 2 switches. Whenever a frame arrives at one switch having some virtual circuit identifier, it will change while it leaves the same switch. That means at every hop the virtual circuit identifier changes. Like circuit switch network, the virtual circuit networks also goes through 3 phases. The first phase is connection setup phase, second phase is data transfer phase, the third phase is connection tear down. Now we will discuss regarding setup phase. In setup phase, a switch creates an entry for virtual circuit. For example, suppose A needs to create a virtual circuit with B. Two steps are required. The step 1 is setup request, step 2 is acknowledgement. During setup phase, source A sends a frame to switch 1 which contains the address of B. So it is a different from data frame. This is a special frame which is meant for setting up of the connection. So this is a setup frame. We call it as setup frame. This frame is going to be sent by A to a switch 1 which is bearing address of destination B. So switch 1, on receiving this setup request, it knows that this frame is going to B. So it has to go through port number 3. So during this particular phase, these switches act like datagram network. So for the moment, assume that it knows the output port. The switch creates an entry in the table for this packet, for this particular frame in the packet, in the table like this. So it is entering through port number 1 and it will going to have a virtual circuit identifier as 14, and the next entry, the outgoing port, which has to be decided, which based on the destination address, which was decided here as 3, it is entered over here. But this particular entry will not going to be there in the table during the setup phase. This entry will not going to be there during the setup phase. So this entry will going to be done only when we get the acknowledgement. So during the setup phase, only these 3 entries in the virtual circuit table will going to be completed. So whatever the setup packet that is entering the switch, it will going to bear a port number 1 because it is entering through the port number 1. So incoming port is 1 and virtual circuit identifier that is assigned by A to it, which is 14, and the port number through which it will going to go out is 3. But what is the virtual circuit identifier that is assigned to it is not defined. At switch 2, similar events will going to happen. So at switch 2, whenever it receives this setup packet, setup request frame, the same events happen here. So the port number through which it is entering over here is entered over here, that is port number 1 through which it is entering the switch 2. Virtual circuit identifier which is free over here, which is available, that will going to be assigned to an incoming port, incoming packet. Then the port number through which it has to go to a destination, that will going to be entered. This entry will going to be empty. Similarly, same set of events will going to happen in third table. So all 3 tables will going to be filled with only 3 entries, not the 4th entry. The 4th entry in these tables will going to be completed during the acknowledgement phase. So during the acknowledgement phase, the destination, once it gets a setup frame, it sends a acknowledgement. So this acknowledgement first, which is sent by B, will going to go to a switch 3. So this acknowledgement frame contains destination address as well as source address, so that switch knows which entry in the table is required to be completed. The frame also carries virtual circuit identifier, which is supposed to be entered into the 4th column. So this particular identifier is chosen by B. So this will going to be entered in the 4th column as a virtual circuit identifier. So moment this entry gets completed, the same acknowledgement frame, while leaving this particular switch, will now going to bear virtual circuit identifier as 22, which will going to be entered into the 4th column of second table. So while leaving switch 2, its virtual circuit identifier will going to become 66, which will going to be assigned by switch 2. So that entry will going to be entered into the fourth column of the table 1. So like this, the table virtual circuit switching table will going to be completed. Next phase is data transfer phase. During this phase, the data transfer happens through the entries made in the table. So already there are entries in the table with the help of which a datagram which is originated from source will move towards the destination with the help of these table entries. So through which port it has to go out, and what should be the virtual circuit identifier that has to be filled in the address field of this datagram is mentioned over here. Using these table entries, those values will going to be filled and the packet is moved from source to destination through specific path. During tear down phase, a source A, after sending all the frames to B, sends a special frame called tear down request. Destination B responds with tear down confirmation frame. All the switches delete corresponding entries from the table and the tear down action will going to be completed. Next, we will discuss regarding delays in virtual circuit network. So, in virtual circuit network, delay will be somewhat similar to that of datagram network. So, we will consider the situation of a network with source and destination and two switches S1 and S2. So, in virtual circuit network, first source need to set up a connection with destination. So, this phase we call it as connection setup phase. So, if destination agrees to have a communication with source, then the setup phase gets completed. So, this we call it as setup delay. Next, after completion of setup, data transfer takes place, which is same as that of a datagram network. Resources will going to be allocated on demand. Then again, this is optional. Then last phase is tear down phase. So altogether it is tear down delay. And this is total delay. So the total delay in case of virtual circuit is clear that three transmission times 1 2 3 3 transmission times plus 3 propagation delays. There is no waiting delays over here like in datagram network, but transmission happens once it receives the complete packet, then only the next transmission starts without any delay, because since already resources are reserved in well in advance, the question of waiting in queue and processing delays will not going to be there. So 3 times in this, the total delay in this case is 3 transmission time plus 3 propagation delay plus setup time plus tear down time. So end to end delay, total delay in this case is 3t plus 3 tau plus setup plus tear down. This completes switching. In the next class, we are going to discuss regarding error detection and correction. Thank you.